Hello again. In this video, I'm going to go over section 2.6, part 8, which is about the intermediate value theorem. And so here's what the intermediate value theorem says. Suppose f is continuous on the closed interval from a to b, and L is a number strictly between f of a and f of b. Then there exists at least one number c in the open interval from a to b, such that f evaluated at c is equal to L. Okay, so to see what this theorem is telling us, let's look at this diagram. So notice in this diagram, we have this function that's continuous on the closed interval from a to b. A is here and b is here, and f is continuous on that closed interval. So the first condition is being satisfied here. The second condition is that we must pick a number strictly between f of a and f of b. Okay, so a is here, so f of a would be there. B is here, so f of b would be up here. So we just need to pick some number strictly between f of a and f of b. So let's say we pick this number L here, okay, which is strictly between f of a and f of b. So we've satisfied both conditions in this diagram. Okay, so the conclusion is there must exist at least one number c, which is this number here, in the open interval from a to b, which it is, such that f evaluated at c is equal to L. Well, when I take c and I evaluate the function at c, I do get L. Okay? So I think this diagram really shows why the intermediate value theorem is true. If you want to get from this point here to this point here, right, from A to B, in a continuous fashion, you must cross this line L at some point. And even more specifically, that point would be at an x value that's somewhere between A and B, right, on the open interval from A to B. Okay? So it's not possible for you to get from this point to this point in a continuous fashion without crossing this line at some point in between A and B. That's what the theorem says. Now, it guarantees that there exists at least one number c in the open interval from A to B. But there could be more than one. And this is an example where you have more than one. So notice L is right here. And of course, the function is continuous from A to B. Okay, L is strictly between f of A and f of B. But notice there's actually 3 points in between A and B where you have a c value that when you evaluate the function at that c value, you get L, right? C1, C2, and C3. Every one of those, when you plug it into the function, will give you a y value of L. So there can be more than one of these numbers in the open interval from A to B where f of c is L. Now, in this diagram, you can see why the function needs to be continuous on the closed interval from A to B. Suppose the function was not continuous on the closed interval from A to B. So you can see here there's a discontinuity at this point right here, right? So f is not continuous on the closed interval from A to B. Well, if L is right here, and again, L has to be strictly between f of A and f of B. So if you pick this L right here, there isn't a point at which the function crosses L. And so there isn't a c in this open interval from A to B where f of c is equal to L, right? It never happens. And so that's why you need the function to be continuous on the closed interval from A to B. Okay, so when applying the intermediate value theorem, as with all theorems, make sure all the conditions are satisfied before you reach the conclusion. So in this case, there's really just two conditions that need to be satisfied. F needs to be continuous on a closed interval from A to B, and L needs to be a number that's strictly between f of A and f of B. So there's really just two conditions to satisfy here. Now, having said that, I'm going to look at this quick check 5 example. So suppose we have this function equal to x cubed plus x plus 1, and we set it equal to 0. And we want to know whether there's a solution to this equation, right? Is there an x value that you can plug into here and get 0 out? On the interval from -1 to 1, on the closed interval from -1 to 1. So is there some x value in this closed interval that we can plug into these x values in this function and end up getting it equal to 0? Okay, well, we're going to apply the intermediate value theorem to see if there is a solution in this interval, this closed interval from -1 to 1. Okay, so we're going to use the intermediate value theorem to show that there is a solution on this closed interval from -1 to 1. Okay, so the first thing we need to do is make sure that this is continuous on the closed interval from -1 to 1. Well, this function is continuous on the closed interval from -1 to 1 because it is a polynomial. Polynomials are continuous from -infinity to infinity, so this is certainly continuous on the closed interval from -1 to 1. So the first condition is satisfied simply because this is a polynomial. Okay, now the second condition is that L must be strictly between f of -1 and f of +1, right? F of A and f of B. And L in this case is the 0. Okay, so let's see if that's true, and I'm going to check that on the calculator to see if it's true. So what you can do if you happen to have a TI-84 calculator is you can go to your y equals button and enter this function into y1, and then I'm going to plug -1 into this function and see what the y value is by going to the calculate button here, which is a second button feature, and then select value, so press enter, and then it's going to prompt you for an x value. Okay, so I'm going to plug -1 into the function, and the y value that comes out is -1, which is this ordered pair here, right? When x is -1, y is -1. Okay, so f of -1 is -1. Now let's check f of +1. So I'm going to go back to calculate or calc the value, but now x is equal to 1, and the y value that comes out now, which is 3, which is this ordered pair right here, 1, 3. Okay, so f of -1 was -1, but f of +1 is 3. Well, L, which is 0, is between those two numbers, right? -1 and 3. Strictly between -1 and 3. So the second condition of the theorem is satisfied. So our conclusion is there must be some number c in the open interval from -1 to 1 where f of c is equal to L, which is 0 in this case. And you can see in the diagram, in this graph, that c is at this point right here. Right, and you can see it's between -1 and 1, right? It's in that open interval from -1 to 1. Okay, so by the intermediate value theorem, we know there exists at least one number in this open interval from -1 to 1, such that when I plug that number into this function, I do get 0 out. And so that's a solution on this interval. Okay, the intermediate value theorem is an existence theorem. The only thing it does is it guarantees us the existence of one number c, at least one number c, in the open interval from A to B, such that f of c is equal to L. But it doesn't tell us what that number is. Okay, it just guarantees us the existence of at least one such number. Now, if you really want to know what that number is, I guess you could look at your graphing calculator, and what you can do is you can go back to this calc button, and then go down to this 0, select 0, so go down to that and press enter, and it's going to find the zeros between your left bound and your right bound. Okay, so I'm going to create a left bound by scrolling over to the left of this 0 here. Okay, the 0 is right there. So the left bound, you can pick any point to the left of it and then press enter. Now notice when you press enter, it gives you this little arrow. Okay, so there's my left bound, and then I'm going to scroll over and create a right bound. So I need to go past the 0 to do that. So this should be good, right? Somewhere over here. And I'll just press enter, and it gives you a little arrow. And so what it's going to do is it's going to find all the zeros between those two arrows. Okay, and now you have to press enter one more time, and there's the 0. Okay, apparently it's at this point here, negative 0.6823278, which happens to be in this open interval from -1 to 1. So there's the C value, okay, that the theorem guaranteed existed. And in this case, there's only one, but there could be more than one. The theorem guarantees there's at least one, okay? And this is the only one in this case. Okay, so if you take this number and plug it into this function, right, you will get 0 out. Okay? Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.